Alright, so let's see, where did we leave off? Did we complete 152 with the cutting of the wire? So let's just pick up here. We're doing this problem. You guys know where you left off. We had this wire that was 8 inches long. We made a cut. We don't know where the cut was made, but then they gave us some information that must be true. So this is something I want to reiterate that's pretty much the essence of solving these kinds of word problems, is you let your variable represent what you don't know. You wouldn't say, oh, let x be the length of the entire wire, so x equals 8. Well, that doesn't really help you. You want to let x be what you don't know, and then you can then write a statement including x, and then solve for x. So we're going to let x represent this piece, which is the length we don't know, this small piece, and then 8 minus x would be, of course, this other piece, it's the whole thing. How far did you guys remember covering on this? Did you guys, we get this, we got all this, or?
Yeah, we got
all that, so then we were on setting up the statement. We were around here somewhere?
On the 32.
Okay, yeah, so so it said that the sums of the areas of the squares must be 2, so I said, okay, 2 is the total area. Boom, boom. If you guys forget these rules, by the way, then you can do it the long way. You can do it x over 4 times x over 4 and go straight across, in case you forget the whole distribution to each the numerator and the denominator, if you forget that. We wanted to get rid of the fractions, so we multiplied everything by 16. Anyone have any questions about this? You're allowed to multiply both sides by some non-zero constant, and it won't affect the equation at all. Now we're here. We expanded this guy, and again, if you forget this, don't worry about it. Just do it the long way and be safe. And now we're here. Before we move forward, any questions thus far on 152? So let's complete finishing this problem. If we go over, I'll go ahead and let's do, what do I have to cover? This thing never wants to cooperate. Like, it's the most complicated thing.
Oh, yeah. You got it.
So we're here, right?
Yeah.
Next line down. Guys, please quit talking. So next line down, we're just combining like terms. We have an x squared and an x squared. 2x squared. The 2x squared. 2x squared, x squared plus x squared. I'm just combining like terms anytime I can. And then we're moving on to, we want this set equal to 0. So I subtract 32 from both sides, and I get this. You can ignore this for right now, that's the next step, but I get this. So just look at this for right now. And then some of you might realize, why did I multiply by 1? Why am I now going to multiply the whole equation by 1/2? Why would I want to do that? I don't have to do it, but it may be convenient for me, because do you notice something? That all of these, they all have a common factor. The greatest common factor is 2. So I'm going to divide out 2 by the whole thing. Remember, I can do that. I can multiply or divide the whole equation by some non-zero constant, and I'll have the same equivalent equation. It just makes it more simple. So if I do that, I would have what? I'd have x squared minus 8x plus 16. And in fact, it probably is even easier to see that, hey, I may be able to factor this doing short AC. Again, I could have gone right into the quadratic formula using this guy right here. We can do that. Anytime we have the quadratic, ax squared plus bx plus c equals 0, boom, we can apply it. We can apply the formula. Yes? Discussion. What's that? Yeah, this is 1/2. Divide by 2, same as multiplying by 1/2. And then, so we have this, right? 1/2 multiplied to each term. You get to here. Now for here, Does anyone know, probably see by the solution, but is this factorable? Yeah, it is. What would it be? What's that? X minus 4 and x plus 4? Close. Careful. Think about the negative 4 and the plus 4. That would actually make negative 16. X minus 4 and x minus 4? Yeah. So again, just to review, because just to make sure that you guys understand, when it's short AC, when this is just a 1, you can just look at this guy and say, okay, what factors of 16 add up to negative 8? Well, they would both have to be negative because they sum to a negative, so they both would be negative 4. So here it is. So this quadratic, I keep bringing up the graphs because we need to know both. What would this look like in terms of the solutions of the roots? How this graph either touches or crosses the x-axis or never touches the x-axis, just based on how you see it algebraically. Yes?
Oh my gosh.
What do you think?
Is it like, it's Heimer, whatever you said, and it's not going to touch it? Or it's just going to barely touch it? You're not giving me any hints.
I will give you a hint. In here, the factors, here it is in factor form. The equation is factor form. Do you see perhaps what you might call a multiplicity? That this guy repeats? Do you see a multiplicity?
No.
Do you see x minus 4 repeated? Yeah. How many times does it repeat? Yeah, it appears twice. So it has a multiplicity of 2.
Oh.
Remember, the multiplicity of 2, if it's an even multiplicity, it just touches. If it is odd, it will go through. Yeah. So this would just touch the x-axis at x equals 4. Yes. So if the multiplicity is odd, it would pass through the x-axis. If it's even, like it is here, because this could be condensed as x minus 4 squared, if it's even, it'll just touch, and it'll change direction at that point. Every single time for polynomial functions. So x equals 4, of course. This is the only solution. So this is where we would say, x equals 4, and then you could specify multiplicity of 2. Thank you. We're going over the homework. So x equals 4 inches. Now, if there were more than one, so if there were 2 different solutions, I would need to test both of those, going back into what is the question asking. So with these word problems, you have to keep that in mind. Don't forget, what is the question asking? What do they want to know for this one? They wanted to know, find the length of each piece, not just one piece, right? So x equals 4, that was the small piece, and the larger piece was 8 minus x. So 8 minus x also happens to be 4. So this particular problem, for this to be the way that it worked out, they happen to be the same length of 4 inches. Now just keep in mind, if, for example, let's say we did the work, we did correctly, and we got x minus 3 and x minus 4, we would have 2 different situations here. One where the small piece is, well, both pieces are 4 inches, and if the other one was x minus 3, that means you'd have to do 3 for the small piece and then plug it into 8 minus x, and 5 inches would be the larger piece, if that occurred. But there's only one solution for this one. That will happen sometimes. I think we had that with, remember 151? There were 2 possible scenarios for that gutter. It could have been a gutter that was, I think, like 9 point something inches of depth, and the other one was like 0.9 or 0.7 inches of depth. But here is only one solution, so there's only one possible scenario for this one. What's that? I still didn't hear.
Don't worry about it.
Okay. If you're coming in late, I've already checked you off in attendance. You were here when I said, yeah, okay. You were here? You were here? You took your backpack to you wanted to say you're kidding? Okay. Okay. You don't have a pass?
I have a pass from my teacher that sent me to the prom, but
That would work. That's fine.
I'm not the end of the class.
Oh, the college room? Okay. Okay, so any other questions? Any other questions about this problem? All right, so let's look at the ones that we haven't looked at yet at all, which are 168 and 172. 168 says the equation 2x minus 3 squared equals 25 is equivalent to 2x minus 3 equals 5. And it says, determine whether each statement is true or false. If the statement is false, make the necessary changes to produce a true statement. They're saying this is, I guess, equivalent to the statement of 2x minus 3 equals 5. And they say the actual wording is the equation this is equivalent to this. And this is half true. Anyone know why it's half true?
Can you tell me what page?
Yes, this is the homework, which is page 155. So if we have something squared equals 25, and we want to solve for, looks like obviously what's inside of the parentheses, 2x minus 3, wouldn't we take the plus or minus square root? So 2x minus 3 would actually equal plus or minus the square root of 25. So 2x minus 3 would be equal to plus or minus 5. So they only gave us half the picture here. So it's almost kind of like a trick question in the sense that it's half true. It's not completely false. It's not totally true. They're only giving half the scenarios here. What's that? Yes, when you take if I have something squared, and then I decide, okay, well, I'm going to square root both sides. If you're taking the even root of a number, it's a square root, it has to be plus or minus to consider all the solutions. We don't have to do anything. I mean, because the question is, it just says determine whether each statement is true or false. If the statement is false, make the necessary changes to produce a true statement. So to produce a true statement, I put a plus or minus in front of the 5. So this is what was missing, you could say. That's, yeah. So let's just go ahead and let's just focus on, okay, if we solve for x for this guy, we're going to have one solution. Right? So if I add 3, 8, and then divide by 2, so 2x equals 8, and then divide by 2, x equals 4. And then for this guy here, I have to consider two statements. I have to consider, and I can't undo that. That I don't like. Can't undo the fact that I changed the whole thing to blue. back here, and just emphasizing this is the emphasis here. So I need to make two statements. I can say 2x minus 3 equals positive 5, or 2x minus 3 equals negative 5. Adding 3 to both sides, 2x equals 8. Divide both sides by 2, x equals 4. Here, adding 3 to both sides, 2x would equal to negative 2. Dividing both sides by 2, x is equal to negative 1. And you can test these, see if it's true, just to see if it work correctly. Plug in 4 into x. 8 minus 3 is 5. 5 squared is 25. If I plug in negative 1 into x, negative 2 minus 3 is negative 5, and negative 5 squared is also 25. So, again, it's like it wasn't completely false, it wasn't totally true, so this one was kind of like it was half true. Yeah, you definitely needed to fill in this detail here. It's actually plus or minus 5. We're just talking about real numbers here. We're talking about real solutions. Let me give you an example to just to solidify what I'm talking about here. If I had something like x cubed equals, let's say something that we definitely know the perfect cube is 8. If I end up taking the cube root of both sides, and again, I'm just considering real values here, I don't do plus or minus here because I took the root that is an odd. And you can even just do it in case you forget the detail which is which. Well, could x be, of course x is 2, could it also be negative 2? Well, let's see, negative 2 times negative 2 times negative 2 is not 8, it's negative 8. That's why it depends on whether the root is even or odd, exactly. Versus something, let's go even something x to the 4th equals 16. If I take the 4th root of both sides, now I have to consider plus or minus the 4th root of 16. What is the 4th root of 16? 2, thank you. So x actually does equal plus or minus 2. There are two other complex solutions that I'm not going to touch on. When you say some number, say something to the 4th power is just some number, there are technically going to be 4 different solutions, but we're just considering real values. We're just considering real values. Just like this guy, he has 2 other solutions that you don't see. You wouldn't see on just like a regular number line, doesn't have the imaginary axis being considered. But there are 2 complex solutions to this one that you don't see. Yeah, when you take an even root of something, if it's an even index, yeah, plus or minus. But I'm saying here, when it was an odd, we did not do plus or minus. Because negative 2 cubed is not 8, it's negative 8. Just a small thing there. Any other questions about 168? And then now the last one we had to number 172. Write a quadratic equation in general form whose solution set is negative 3, 5. Okay. This one is very simple if you can think about maybe what's on that board already. When you're working out problems, so you start off with something that's in general form here. And then eventually, if you can factor, and these are nice integer solutions, it says it needs to be negative 3, 5. Well, what would it look like in factored form? If these are the solutions, remember, solutions are zeros or roots, all mean the same thing. If these are the solutions, what would the quadratic equation would have looked like? It would have been x plus 3 times x minus 5. And then now just go ahead and expand it and simplify it to have it in the general form that they want. This is what they want. They want the general form. So then we go ahead and FOIL x squared minus 5x plus 3x minus 15 equals 0. X squared minus 2x minus 15 equals 0. And that's the general form we're looking for. Ax squared plus bx plus c equals 0. So if you give me the solutions, I'm gonna go, and you want me to give me the general form of the equation, I'm gonna go right to this idea here, okay? Well then in factored form it was this. X plus the opposite of our equation was. Because then it goes intuitively, if I plugged in -3, it would satisfy it. If I plugged in 5, it would satisfy the equation. Any questions about this? Makes sense to do it this way, the easiest way to do it. For the quiz on Monday, you are going to need to know. Yeah, the thing that I've never given you yet. What's that? Can you get a 0? I'm sure you can get a 0 on a lot of things in life with that attitude. It's not even an attitude. I mean, it's kind of a ridiculous question. You can easily get a 0. I guess if you just don't do it. So, do you guys want to know what's on the quiz?
Yeah.
Okay. So, you need to be able to look at a quadratic function, y equals ax squared plus bx plus c, where a and b and c are real numbers, and tell me whether it opens upward or downward. Okay, so remember, if a is positive, if this a coefficient, the number in front of the x squared is positive, it opens up. If it's negative, it opens down. You need to be able to identify the vertex of the parabola when you're given a graph of it. Very simple. You look at it, boom, there it is. When you're given the graph of it. You just say, oh, there it is. What's the coordinates of it? That's it. You need to. You guys want to know what's on the quiz? I'm going to stop talking. Okay, well, everyone's chit-chatting. If you have a question, you can ask me and I'll tell you. How many questions are there? It's not going to be too long. It's going to be short enough so that you can complete it, within the time. I have, looks like 5 or 6 multiple choice, which are pretty quick and easy. And then I have some problems you actually have to work out what are not multiple choice, which are very basic compared to those. See, I'm making you guys think really high here, and I'm thinking it'd be cool if I give you quizzes down here.
Yeah.
You know what I mean? If I can do this, oh wow, this quiz is nice, right?
All right, great.
Okay.
What's on it for that?
We do have calculators in these boxes here if you need one. Yeah. So if I didn't mention that to you guys, I think maybe I did. There's calculators in those boxes.
Whatever.
Make sure you return them when you leave the class set.
What we did for homework is
Whatever we did for homework is on the quiz. So again, the homework problems, especially 151 and 152, those first two are going to be considered more advanced compared to what I'll be giving you on the quiz. So I will give you an example. Let me make sure I circle the one that I'm not going to actually do. So something like this. And if someone wants to come up here and try it, that would be awesome. It says something like the sum of two numbers. Are we going to have word problems? Is that what you're going to ask me? Yes, we're going to have word problems. But they are going to be much more simple than 151 and 152. All right, who wants to take a shot at it? Go for
Only
it.
I want to take a shot.
Go
Hold
for
up,
it.
hold up, hold up, hold up.
So solving multiple.
I want to see if someone, well, I'll have to see if someone can come up and explain it. You want to come up and try it?
Yeah, I do.
Or you can tell me what to write, it's up to you.
No, I think I want to come.
All right, awesome.
But I'm just stepping in.
You got it. I think you know what to do. I think you know what to do. I'll guide you if you get stuck.
Okay.
Thank you.
Should I write out like the whole equation first?
I want you to explain it to us like we have no idea what you're talking about,
Okay.
including me.
All right. Okay. So, if the difference is 41 and the sum of the numbers is 31, I have to find the number greater than these two. Correct? That's higher than 41.
Okay, so
Or higher than 31.
what is the I said it earlier in this class about the start of these problems is, and it's kind of the essence of these kind of word problems, is what do you want to say, like, for example, use a letter or a variable for example.
Okay. Can we use X and Y?
Sure.
Okay. And if X minus Y equals 41, right?
So what would X represent? What did you say? Did you say something?
No, I didn't say that.
What is X and Y? What are they?
The two numbers that
Sure. So if X is one number and Y is the other, then you're doing well. You're doing everything's correct.
It's being simple on my basis.
What does difference mean?
Subtract.
Mm-hmm.
But I'm saying like I subtract X from what?
It says their difference is 41.
So the same number.
Mm-hmm. Their difference is 41, yeah. Find the numbers. So this, okay, I don't want to say too much. This should be a review though. It should feel like a review. You know, it's a very simple system like this.
Is this
Do you remember the substitution or elimination method for solving a system of two variables?
no, I mean not at all.
Not at all?
No.
Not at all.
I don't remember how to start it. That's like
Ooh.
me.
Ooh. Why don't you go ahead and you can choose one, substitution or elimination. Which one do you prefer? Or you're not sure?
Elimination.
I like elimination too. Do you see how one of these variables could eliminate pretty quickly?
Yeah.
Okay, so go ahead and go down that road of doing that. Okay. So what are you doing? You're adding everything?
I don't know. You just said
Yes.
no.
Yes.
Okay.
Add all the components on the left-hand side.
Okay. So X plus X.
So X plus X. Let's work down though. Let's draw a big bar underneath the whole thing.
Big bar.
Yeah. Yes, there we go. We're going to add all the components on the left-hand side of the equations. So x plus x.
2x.
And y plus negative y is nothing, so we don't have to write anything. Equals, now 31 plus 41 is 72, and then to solve for x, okay. Now how do you find, good job, how do you find y?
Plug it in.
Yeah, I can plug it into which equation? Someone says either or, do you agree?
Yeah, because they both do the same thing, right?
Yeah, they're both part of the same system. It better satisfy both, otherwise you made a mistake leading up to that, so yeah.
So I should do both, like I should put them into both of them?
You don't have to, but you can do it to check your reading, to check your, make sure you're not making a mistake.
Well, I'll start with this one.
So we got
It's a good way to check to see if you made a mistake, right? If you plug it into both, it better satisfy both. You better get the same y depending on which one you put. That's what I'm saying. So you just need to substitute whatever you have for x into x and solve for y. And it shouldn't matter which one you pick. Now you're just solving for y.
Minus 36. Nice. Okay.
There we go. There we go.
I'm doing this one.
So, and let's circle our solutions. Make it clear for the teacher to grade. Yes. Why would you not circle that? That's part of that's the other number. It said find the numbers. It didn't say find the smaller number. There you go. Awesome. This should be a review for you guys, yes? Coming from algebra.
That was one part.
I just didn't know.
It is.
Okay. It's a very basic one.
I didn't take my algebra last year. So
Okay.
I took pre-calc.
Does everyone understand the elimination method or substitution method? It should really feel like you guys are great at topics.
If you substitution would have been like entering the x plus y into the other one,
You would solve literally for x or y and then plug whatever that is into that variable.
is this substitution or elimination?
So let me get my question the other way.
Elimination, that's what we just did.
Okay, so I'm asking if this.
You can do whichever one you can do whichever one you want.
I know I want to be
So I'm going to show the other one too.
I might as well then delete that.
So if I use the original one and I write it literally for x, if I subtract y from both sides, would you agree x equals 31 minus y?
Yes.
I'm going to take this value and plug it into the x of the other equation, right? So 31 minus y equals 41. So 31 minus 2y equals 41. So negative 2y equals 10. Divide both sides by negative 2, so y equals negative 5.
Do we have to be able to do both of them?
I'm going to say for this quiz, you can do whichever one you want. Whichever one you're comfortable with.
This one give us the answer.
Yeah, it's a good question. It doesn't matter which method you use. They give you the correct solutions. And of course from there, now that you know y is negative 5, since you plug it into either one of the originals. Another example. They'll be available on Blackboard at the end of the day if you need to look up things. So next one I want to look at is the problem that this will be something like on the quiz. One side of a rectangle is 3 feet shorter than twice the other side. Find the sides if the area is 209 square feet. So this is more like what you guys have been doing. (209 square feet). Okay? So here's what you guys need to get. I cannot say this enough. I'll keep repeating myself over and over again. What's the most important way to start this? Visualize is good. Write the math. The variable. So this is what I really want you guys to do. Let x be what you don't know, what you're trying to find. And if you have to do let y be something else that you don't know, then do that. And then you can develop a statement out of that. So what do you want x to be? Let x be what? The short side, the long side? Short side. This is where you don't go x equals 209 square feet. That doesn't help you, right? So we're letting the variable that we don't know. Let x be the short side, and therefore let y be the long side. And then now you start writing equations that are true based on what you're letting x and y be. Because this is what you don't know the length of the short side, you don't know the length of the long side. That's when you let you be your variables. Okay, so now let's write some statements from this. One side of a rectangle is 3 feet shorter than twice the other side. Don't worry about, by the way, oh wait, which one's longer, which one? So let's actually make this even more simple. Let x be one side, let y be the other side. You're going to see which one's which. It doesn't matter. There's just labels here. So let x be one side, and we'll let y be the other side. I know. One side of a rectangle is. One side of a rectangle is 3 feet shorter than twice the other side.
Oh.
3 feet shorter than twice the other side. The other side is y. Twice y is 2y. 3 feet less than that would be 3 feet shorter than twice. Find the sides if the area is 209 square feet. We had a problem like this, the cross-sectional thing. Do we know the area of a rectangle? Say it again. 209 equals. Before we even get there. And then substitution. And it's all. You have a quadratic. This is the key. If you can't get this, you can't go any further. So you guys need to be familiar with like problems 151. This is just like 151. One side of a rectangle is 3 feet shorter than twice the other side. Find the sides if the area is 209 square feet. So x and y is 209. So I'm going to substitute this into my x. Please don't talk. Please quit talking. If you have a question, you can raise your hand, but please don't talk. 209 equals 2y minus 3 times y. All I did was substitute this value into my x here. So that's all I did. And now it's quadratic. Expand a squared plus bx plus c equals 0. There's nothing confused about this.